In this video, I'm going to be performing quite an interesting upgrade on this late 2011 17-inch Apple MacBook Pro. Now, this upgrade is going to be quite interesting because it is going to drastically expand the capabilities of this machine. So what I have in front of me here is a product by iBoff called xGPU, and basically what this is it is a PCB that goes into your optical drive slot, along with some other components, which I'll show you in a second, that essentially allow you to add NVMe SSD support, and this is native NVMe, as well as an eGPU slot right here. As you can see, it's a X8 PCIe slot that you can use to connect an external video card or any other external PCI Express peripheral to a 17-inch MacBook Pro or 15-inch or even a 13-inch, you can see right there, through its optical disk drive slot. And then, of course, in addition to that, we also have the ability to add a SATA drive here in place of the original optical drive interface there. Now, if we flip this over, you can see some of the other components that this comes with here. So we've got a couple cables. We've got this PCB right here, which is quite interesting. Basically what this does is it takes the place of the defective AMD Radeon HD 6000 series chipsets that these machines use, and provides a breakout in the form of these ipex connectors here, which go into these connectors, which then plug into these connections on the optical drive PCB here. And we can also see we have another one of those interposer, or not really interposer, but breakout PCBs right here. And this one goes in place of the Thunderbolt controller. And this is what will provide 4 PCIe lanes for use with the NVMe SSD. Now, this kit is not currently for sale from iBoff at this point, but it will be sometime in the near future. So if this is an upgrade that you desire to perform, you can indeed buy this kit. It is a lot of work to perform this upgrade, as you'll see in a second, but it is well worth it in my opinion. So you will be able to buy this in the future, and when you do buy this kit, it also will come with these extra PCBs and cables, which will allow you to connect an external ATX power supply, as you can see right here, to power a external video card if you install one. You can see it also comes with this PCB, which allows a full X16 slot, along with some extra power from that other PCB I showed you earlier. And then this, of course, will plug into the optical drive into the PCI Express connector on this board right here. So with all that out of the way, the first thing we need to do, of course, is to remove the logic board from this machine, and then we'll begin the process of replacing both the Thunderbolt IC as well as the AMD Radeon 6000 series chipset with the 2 interposer, or the 2 breakout boards provided in the kit. So with that, I'm going to go ahead and get the board out and then resume the video. Alright, so as you can see here, I've gotten the board and the board preheater now. I went ahead and put it in here because, of course, the first step to begin this process is we're going to remove this defective AMD Radeon HD 6000 series chipset located right here, of course. So, of course, the first thing we need to do before we do that is to remove the little pieces of edge bonding on all 4 corners of it. So go ahead and do that real quick. And to make it so easy to do, I've just already started heating the board up. It's at about 150 degrees Celsius right now, and at that temperature these come off very easily because they're very soft at that temperature. Alright, and now with all those removed, the next thing we need to do is just apply some flux to the chip. And with the flux applied, we can go ahead and increase the board temperature up to about 170 degrees Celsius, and then we can begin removing the chip. So in order to do that, I'm just going to use my hot air nozzle here. Positioned over the chip evenly like so. And now that the board has gotten fully up to temperature here, we'll go ahead and turn on the hot air and begin removing the chip. Alright, the chip is now ready to come off, so we'll go ahead and remove it. Alright, and of course now that the chip is removed, the next thing we need to do is remove all the residual solder from the pads. So we'll go ahead and do that using my soldering iron and some solder wick. Of course, the first thing we want to do is just use some fresh leaded solder to remove all the residual leaded solder, or the big pieces of lead-free solder rather. Let's start by applying a little bit of extra flux here. And now we'll use the solder to remove all these big chunks before we go with the solder wick. Alright, so now we've done that, we'll just go back over it again with some solder wick and remove the rest of the solder. Alright, so that looks to be all the solder removed, so we'll now go over it with some rubbing alcohol on a paper towel to remove all of the old flux. Alright, so there we go. All of the old flux has now been removed, and all the pads look to be perfectly clean, which is exactly what we want to see. So now we are ready to begin soldering on the breakout PCB included with the xGPU kit. So if we go ahead and take a look at it right here, you can see that the board, the PCB here, actually has solder balls on the back of it, just like the original chip did, of course, in the same ball out as the chip. But as you can see, it's missing a lot of them, and that, of course, is because we're not using most of the I/O, only the I/O needed for the 8 PCI Express lanes. And as you can see on the other side, we've got the 2 connectors for the ipex, which go off to that optical drive breakout board, or distribution board as they call it. So with that, I'm going to go ahead and get this board aligned onto the MacBook board, and we'll begin the process of soldering it on. So of course, the first thing we're going to do here is just apply some fresh flux to all the balls, or all the pads of the chip here. And that, of course, will just ensure that all of the solder balls on the breakout PCB here solder as expected. So with that, we'll go ahead and make sure we got pin 1 in the correct orientation, and just place the board down onto the MacBook PCB here. I want to make sure it gets flux on all the balls underneath before we remove it again and remove all of the excess flux, which I may or may not do for this board because there's not that many balls. And as you can see, it is getting a decent amount of flux on there, so I don't think we need to worry about that. So I'm going to go ahead and just place this back down here. And of course, the most difficult part of this is getting it properly aligned onto the pads of the board. So in order to do that, I'm just going to get it aligned in one known direction. So go ahead and get it aligned vertically first, and then we'll just kind of push it on. Alright, it's definitely considerably more difficult to align that than it is a normal GPU chipset, but it looks pretty good there. So I'm going to go ahead and realign the hot air on top of the breakout PCB and solder it on just like a BGA chipset. Alright, that looks pretty good and soldered there, so we'll go ahead and turn the hot air off and let the chip or let the board cool down. Alright, so now that we have gotten the breakout PCB on the board, the next thing we need to do is we need to remove and replace all of these AC decoupling capacitors right here with some inductors, or basically just straight through, and just remove the capacitor. And the reason for that is, according to the PCI specification, or the PCI Express specification rather, a peripheral, or a PCIe peripheral, must have AC decoupling capacitors on each end of the differential pair closest to the peripheral. Now, of course, since we're removing the GPU chipset here, the peripheral is no longer located here, but will be located at the end of these ipex cables here. So basically we need to remove the AC decoupling capacitors here and bypass them, because the other PCB, as well as any GPU or NVMe SSD or what have you that you install, will have the AC decoupling capacitors on it already. And of course, if you have redundant capacitors like this, it will cause severe signal degradation. So with that, what we need to do is I'm going to get the hot air turned on here, or the board preheater. I've got the small one here, as you can see. So go ahead and get that warming up here. And then we're just going to use the hot air to remove all of those capacitors and replace them with these tiny inductors that were provided with the kit. So those are 0201 size, so those are the smallest SMD components you can get. So as you can see, they are very, very small, but they shouldn't be too big of a deal to install. So with that, I'll go ahead and get the hot air going and start removing all of these capacitors. Oh, and by the way, there's only 16 on this side, and there's 16 more on the other side, or there's 32 in total. I don't know. I think they split them in half, but of course we'll just replace the capacitors on this top side, and then there's about the same amount of other capacitors on the bottom side of the board we have to replace. So with that, I'll go ahead and get the hot air warming up. Alright, and with the hot air up to temperature here, we're just going to apply some flux to these capacitors. And just heat them up and remove them one by one. Okay, and now with those all removed, what I'm going to do is I'm going to apply some fresh solder to the pads. That way reinstalling the new inductors will be a lot easier, and I won't have to heat them nearly as much. Alright, so I've gotten some fresh solder applied to those pads, so now I'll just go ahead and start installing the little inductors here. Alright, so that's all the inductors on the top side, so now I'll have to replace the other 16 on the bottom side of the board. Alright, so as you can see, I have gotten the board flipped over now. So the rest of the inductors, or rest of the AC decoupling capacitors we have to remove and replace are located right here. As you can see, there's 4 here, and then there's quite a few right here we need to replace as well. So I'm just going to go ahead and do exactly what I did on the other side. Remove them and replace them with the little inductors. Alright, so that's pretty much all of them on there. Now I did lose a couple along the way, so unfortunately I'm missing just one to finish this last edge here, or this last set of pads here. So for those, I'm just going to bridge that with a little bit of solder, and it'll work just the same. There's no really reason to worry about that. They're just basically bridges anyway. So I'm going to go ahead and put a bridge of solder on those 2 pads, connecting them, and then we'll be all set. Alright, so I know you really couldn't see exactly what I was doing in those last shots there, just because the angle was so weird. It was kind of hard to get a good shot at. But as you can see here, if you look at where the AC decoupling capacitors were, you can see they have all been replaced by those inductors, which are a much lighter color than the capacitors that were there. And if we go ahead and flip the board over, you can see the other set of those inductors that I installed. And as you can see there on the very end, I did find that last inductor that I was missing, and I was able to install that as intended. So now every single position has an inductor as it's supposed to, and I did not have to bridge any using solder. So with that, we're going to proceed with the next steps, and that is connecting the GPU reset line, so EG reset L, to PLT reset L, basically. So in order to do that, I'm just going to solder a bodge wire, just a 0.1mm piece of copper wire. I'm going to connect it from EG reset L to PLT reset L. And one thing I should note is that the GMUX IC right here has a copy of my DMUX GMUX IC firmware flashed on it, so it will not interact with the dedicated video chipset, or what used to be the dedicated video chipset in any way. So the guide recommends disconnecting EG reset L from the GMUX IC, but that is already done with the DMUX firmware, so I don't need to worry about that. All I'll need to do is connect EG reset L to PLT reset L in order to forward the platform reset to the GPU chipset, and of course normally the GMUX would provide that, but in this case it is not. So we'll go ahead and solder that jumper real quick, and then we'll proceed from there. Alright, so in order to solder our necessary jumper wire here, the first thing we need to do is locate the pin on which EG reset L, or a position on the board where that is present. So to do that, I'm just using this schematic. I've got it pulled up on a computer over here. So I have located EG reset L. It can be tapped off of this resistor right here, so the fourth small resistor up here, so it would be that position of that pad right there. The resistor itself is not actually present in this case. So what we're going to do is just turn on the soldering iron, apply some flux to that point, tin that point, and then we'll solder a jumper wire to it. As you can see, I've got some jumper wire right here. I've already tinned that, it looks like, so I can just go ahead and tack it down. Alright, so that side is connected, so now I just need to find a point where I can locate PLT reset L. Looks like there's quite a few spots where I can do that, and it looks like the easiest is going to be either side of, or the inner side of these two components right here. So it looks like they're just two resistors, so I'll just tin one side of those. Just like so. We can tin our wire. And simply solder it to that point. Just like that. Alright, and now that we have PLT reset L connected as intended, we can move on to the next steps. And I believe the next step is probably going to be, we need to move one more, or attach one more jumper, and it looks like that would be PEG clock rec L, or clock request L, and we just need to put that to ground. So I'm going to go ahead and locate a pin where we can find that, and it looks like that is going to be over here somewhere. Make sure it's in the shot here. So yeah, it looks like that's going to be over here, so let's go ahead and locate those that resistor that we need to solder to there. And it looks like it is this one right there. So we'll do the same thing we did again. We'll just tin that. Solder a wire to there. And then just find the nearest ground point that we can use. So it looks like these capacitor pads are connected to ground over here. So yeah, we'll just go ahead and use this big ground pad right here. Alright, and that is now done. So we have our necessary jumpers. And if you're wondering about this jumper, this is actually just left over from a previous experiment. So this one is not necessary. But of course these two are. This one is connecting EG reset L to PLT reset L, and this one is setting PEG clock rec L to ground right there, so that will always be enabled. So the last thing we need to do is to simply install the ipex connectors onto the breakout PCB right here. So I'll just need to get that back on the hot air. And of course it'll just be those two positions right there where we'll solder our connectors onto, and then we'll be ready to go with that upgrade. And then of course we'll move on to the second part of this upgrade, which is the Thunderbolt IC replacement used for the NVMe drive. Alright, so as you can see here, I've got the board back on the board preheater once again. So the first thing we're going to do is just apply some flux to these pads here. And then we're going to go ahead and tin those with some fresh leaded solder. Alright, now I've got our two connectors already prepared here. So I'm going to go ahead and just place those onto the board like so. Make sure they're pretty well aligned like so, and then I'm just going to use the hot air to solder them on. Now this hot air is at a decently low temperature, so it won't melt the plastic that's in these connectors. Okay, so there's one installed, so you can check to make sure the pins solder just by kind of tapping on them, and it looks like they might not be quite soldered on, so I might go over them manually with the soldering iron just to make 100% sure they're fully soldered. Alright, so I went ahead and inspected that one. That one looks pretty good. So we'll just go ahead and solder on our second one and go from there. Alright, now we'll just go over that with the soldering iron, just like the last one. Alright, and there is the second one completely soldered. So that should be the complete installation of the xGPU kit, including all jumpers and everything. So now we'll just go ahead and move on over to installing the NevBolt, which is the NVMe breakout board, which goes over here where the Thunderbolt controller is. And if I can even install that on the 17-inch, I don't know if that one's compatible exactly with the 17-inch, but I'll verify that and make sure before doing anything in that regard. So with that, I'm going to go ahead and get the board prepared for installing the other breakout PCB, and we'll go from there. Alright, so after doing a little bit of research, I did find that this board can have the NevBolt installed, which is this little chip right here, or this little breakout PCB here. So you can see it'll replace this chipset right here, and it actually did not come reballed. So actually, before I do this, I will actually have to reball this. So with that, I'm going to go ahead and get the board out of the way here, and we'll begin the process of reballing that breakout PCB in order for us to install the NevBolt. Alright, so as you can see here, I've gotten the reballing stencil ready to go here with the NevBolt underneath it, as you can see. I did actually pour some solder balls on it already just because I was trying to figure out the correct size solder ball for the stencil, and it looks like it is 0.5 millimeters. So I'm just going to use these. And of course we'll get the rest in the holes using some tweezers. Alright, so all the solder balls are on there, so let's just go ahead and heat them up. Hopefully this is a direct heat stencil. I don't know for sure. Alright, there we go. One of the balls was being a little stubborn and wasn't melting onto its pad, but I got it now. So now the board, as you can see, is completely reballed, and it is ready to be soldered onto the MacBook logic board. So with that, I'm going to get the MacBook motherboard back up here, and we'll begin the process of removing the Thunderbolt IC and get this chip installed. Alrighty, so now with the board up to temperature once again on the preheater here, we can now begin the process of removing the little edge bonding pieces around the chip. Alright, and now that that's done, we'll just apply some flux to it and begin removing it. Now, of course, since we are removing the Thunderbolt IC to perform this modification slash upgrade, of course, you will no longer be able to use the Thunderbolt port once this chip is gone, of course. So with that, we'll go ahead and begin removing it. Alright, so as you can see, I got the chip removed there. So while the board's still hot, there are a few other things we need to remove. Namely, all these AC decoupling, or all these capacitors down here. These are for the Thunderbolt port and will just get in our way when we try to install the board. We have to remove this screw hole right here, which is for the heatsink that went over this chip. And then we also need to remove these AC decoupling capacitors over here to replace with inductors, just like we did with the GPU chipset. So I'll go ahead and just start removing these now. Remove this screw hole. And we'll remove these AC decoupling capacitors over here. Oh, and one more thing I might need to do is I need to move this capacitor right here down just a little bit, because it is in the way. If I just move it out of the way now, we should be all set. Alright, that should be well enough out of the way. I just kind of nudged it down as far as I could. Of course, keeping it on the pads. I'll move it later if I have to, but I think it'll be okay for now. So with that, of course, the next thing we need to do is remove all of the residual solder. So we'll just do that exactly like we did with the GPU chipset. Apply some fresh solder to the pads where we'll be soldering our inductors. And I'll go ahead and clean the excess flux off the board. Alright, and with that clean, we'll go ahead and apply some new flux. And then we'll take our NevBolt PCB here and solder it onto the board. First I'm going to make sure it's fully aligned before soldering. And that looks pretty much good right there, so go ahead and remove this solder ball that somehow got stuck to it. And now we can go ahead and heat it up and solder it onto the board. Alright, and there it is, fully soldered onto the board. So now we can just do exactly what we did with the GPU chipset and apply those little inductors in place of the AC decoupling capacitors. Alright, so I've gotten the pads all prepared to install the AC decoupling capacitor replacements, which, like I said, are just little inductors. Luckily, these are considerably larger than the 0201 inductors that I had to install for the GPU PCI Express lines. And these are actually, for one, we have less lines we actually have to install these on, and they're 0402s instead of 0201s. So they just go on these pads here, and then there's a set of 8 more on the other side, and I believe that is the total amount. So let's go ahead and get these installed. Alright, now with those all in place, we can just go ahead and flip the board over and do the 8 on the other side. Alright, so as you can see here, I've gotten the board flipped over, and the capacitors we need to replace on this side are located right here. So go ahead and just start by applying some flux as usual here. And we'll just go ahead and remove them. Alright, now of course we'll just apply some fresh solder to the pads. And we'll now solder on our new inductors. Alright, and now that we've gotten all those inductors installed, the next thing we need to do is remove a load switch that basically disables and enables 3.3 volts to this IC depending on a signal. The IC in question is only rated for 2 amps worth of current being drawn through it, so we need to remove it and bypass it with a blob of solder. That way a 3.3 amp NVMe SSD can be used without issue. So let me go ahead and locate that component real quick. And it is located on the opposite side of the board, so we're just going to go ahead and flip the board back over one more time, remove and bypass that load switch, and then we need to run one jumper wire, and then we're done with this installation. So I'll go ahead and flip it over one more time and show you that process. Alright, so as you can see here, I've gotten the board flipped over one last time here, and the IC in question is a very small BGA chip located right here under this blob of I guess edge bonding is what it looks like. So we need to first remove that. Just like that. And then it's as simple as applying some flux to it and removing it using the hot air. Alright, so now that that's off, I'm first going to go ahead and just apply some fresh solder to its pads, and then we will need to short out the top 4 balls there, the top 4 pads. It's basically 1, 2, 3, 4, and kind of like a square pattern. So we'll go ahead and get the soldering iron turned on here, and go ahead and remove solder there. And in order to bridge the pads, I'm just going to remove the flux off of it there. and then get some fresh solder on my iron and just connect those 4 top pads. Alright, so that looks to be all 4 shorted there. It's kind of hard to do because, well, solder will not bridge like that if there's just flux on it, and when there's no flux it makes it hard for the solder to flow, so it's a little tricky to make little bridges like that. But it looks good. It doesn't look like there's any issue there. All 4 seem to be connected, and I'll verify that later under the microscope. But for now, while we've got it on the heater here, let's go ahead and install the ipex connector for this side. Let's go ahead and get it out of its little packaging here. And just like before, we'll start by just tinning the pads on the board. Go ahead and tin those as well, because we will need those very soon here for our jumper wires. Alright, all our pads are tinned there, so go ahead and get our connector and place it onto the board. Of course, we need a little bit more flux first. Alright, now that that's in position, we'll decrease the hot air temperature, of course. And once that comes down to temperature, we'll solder it on. Now that actually looked to have soldered on the pins decently well there, but I'm going to go over it one more time just with a little bit of solder, the soldering iron, just to make 100% sure. Alright, and that looks about good there, so I'm going to go ahead and verify that, and then we'll go ahead and run the last couple jumper wires. Alright, so as you can see, I've gotten the board off the board preheater once again, so now we'll begin the process of installing the last jumper wire that we need to install. And that will simply connect to the reset pad of the breakout PCB here to PLT reset L on the board. So we'll go ahead and find our nearest location for that. And somewhat annoyingly, it looks like the nearest point for that is on the opposite side of the board. So I'll go ahead and just connect that as I need to, and I'll connect it from here, probably go around this fan section here, and then connect to the pad on the back side of the board. So first thing we'll do, of course, is just solder the jumper wire onto the reset pad. Alright, the reset wire is connected, so we'll go ahead and flip the board over. And now we'll connect it to the closest spot I can find on this side of the board. So it'll probably end up being right next to the other one that I did for the video card. So we'll go ahead and just cut that wire about right there. Or actually, I'll tin it and pull it off. So yeah, we'll solder it right next to the one we did before. Just like that. Alright, so now that is connected to PLT reset L as well. So that is that jumper done, and we do have to solder one more wire, and the last wire we have to solder is for the 3.3 volt rail connecting to the NVMe SSD. So now we'll flip the board back over one more time, and we've got one more wire to solder, and that wire will be a connector that comes with the kit, and that will solder to this big pad right here. So I'll go ahead and get that wire real quick. Now the way he's got this set up here is he's using both of the wires on this cable here, and basically it's just got a little connector on the end, as you can see there. He's using both of these as 3.3 volts, so he's just tying them together. And the reason for that is the distribution board that goes where the optical drive goes is grounded in many other places, so he doesn't need to use this as ground, and he can use both of these to send more current over to the NVMe SSD. So what I'll do is I'll kind of twist these together as best I can here, and then we'll take them and simply solder them to that pad. So, there we go. Alright, and that's the last thing we have to solder, and this of course will go all the way over to the optical drive and plug in there. So that is the completed installation of all the components we need. So let me go ahead and show you a close-up of that real quick. Alright, and as you can see, that is the finished installation. So if we take a look, you can see we've got the wires soldered to that pad there, both tied together. We've got the reset pad tied to PLT reset L on the back of the board. And of course, we've got the xGPU installed right here, along with the AC decoupling capacitor replacements, which of course, like I said, are inductors. You can see they are located right there, very small 0201s. We did the same over here. These components here, these two, and these two, we replaced. And then on the back side of the board, you can see we've got that PLT reset L wire going down to this section right here, which if we look at the schematic, I'll show you real quick, is PLT reset L or PLT reset buff L. As you can see right there, both of the spots of that resistor are that same rail. So I am using both of those for my PLT reset L wires, as you can see right there. And I've got one connected up here to where the GMUX IC is, which connects straight to the DGPU chipset pinout up there. And then I've got the last wire here, that PCIe clock rec L. I have that connected straight to ground right there. So that has been the completed installation of both the xGPU and the NevBolt from iBoff. So now what I'm going to do is I'm going to ultrasonic clean this board because there's way too much flux in all these ipex connectors to actually plug anything into them. And then from there we can finally test the machine. So I'll get the ultrasonic ready, get these ultrasonicked, and once everything's ultrasonicked and dried, we'll begin testing. Alright, so one thing I forgot about before we begin testing this board is you actually have to make a small modification to the original heatsink. And in order to do this, or the modification that needs to be made, is you just have to remove this screw bracket for the GPU chipset here, as it gets in the way of the connectors that we installed for the cables for the eGPU side of things. So in order to do that, these are brazed on, so you have to use a torch such as this, a brazing torch, propane torch, and just heat it up until it melts the solder that holds it to the other parts of the heatsink, and then it should just come right off. So I'll go ahead and do that now. Alright, so it's been successfully removed. I don't know if I'm going to take the copper piece off or not. It shouldn't be an issue, so I'm probably just going to leave it. But now the heatsink is ready to be installed on the board. Alright, so as you can see here, I did get the board out of the dehydrator and ultrasonic, and it is now perfectly clean. As you can see, there's no more flux around any of the connectors or anything, and everything is still soldered on as expected. So I did also have to remove the little copper piece on the heatsink, because if I go ahead and put it on here, you can see how it would get in the way if it was there. So you can see that the heatsink kind of goes right over there, and the screws of course will hold it a little bit above, but without that copper piece there is more than enough room in there to run the wires through. So I'm going to go ahead and get some thermal paste applied onto the CPU, get all the wires connected as intended, especially these two for the GPU, and then we'll just screw the heatsink on, check everything, and see if we can get the board back into its chassis. Alright, so as you can see here, I've assembled it as best as I can. So the speaker was a little bit of a tight squeeze because of this cable here. It was kind of in the way of the little cone that goes underneath this speaker. But other than that, everything else is free. This cable is free under there. It's not being pinched. It's only this one that's being a little bit pinched, but it shouldn't be an issue. As you can see, I've also connected these two cables here, and they go under that heatsink just fine. I'll go ahead and show you it from the side. You can see that there is plenty of room under that heatsink for those cables now that that screw bracket has been removed. So now, of course, the next thing is to just install this board back into the chassis. Now, the only thing I'm a little worried about here is it looks like this cable might be ever so slightly too short to fully reach to the optical drive. So hopefully that isn't the case, but I'm gonna just give it a test fit and see if I can't get it to just stretch out long enough to plug in to the connector on that little optical drive PCB. So with that, I'm gonna go ahead and see what I can do, what I can make fit into the chassis, and we'll go from there. Alright, so as you can see here, I got it in the best as I could here, but unfortunately my suspicions were correct in that the cable for the NVMe drive, this cable right here, is indeed too short for the 17-inch system. The GPU ones went in just fine, but the NVMe one is definitely too short. So unfortunately, just to test that for right now, I'm going to keep the board kind of half disassembled, as you can see here. Now, I will mention I did also have to remove this piece of plastic here, as well as this speaker right here temporarily, just so I could fit this board in. Now, you will have to probably modify those items, or at least the speaker, to fit in here as intended, but for now I'm just going to leave it out for testing and just so I can make sure everything works. So with that, I'm going to go ahead and get the NVMe drive installed. I've just got a little 128 gig testing one here, and then we'll power it on and see if at least that works right now. And then I'll just unplug this cable and then fully reassemble the system. That way we can test the external GPUs separately. So with that, I'm going to go ahead and get the NVMe drive inserted and we'll power it on. Alright, so as you can see, I've got an NVMe drive installed now, and one thing I want to mention real quick is I did actually have to cut this trace connecting EG reset L to the GMUX IC because it was keeping the GMUX IC in reset and wasn't allowing it to display backlight as it was supposed to. So unfortunately, that must be the hardwired to the reset pin of this FPGA, so it's nothing I can control via the firmware. So with that, I'll go ahead and plug it in, and we'll see if it boots. So far, so good. And as you can see, it is indeed booted, or at least it's posted. I'm holding down the Option key on an external keyboard now, and once it loads the boot menu, we'll be able to select the external SSD I have here as our boot drive. So it is going to be a little slow because I don't have a battery connected, unfortunately, but not much I can do there. I've actually got to boot into this volume. This is running a copy of Catalina, and as you know, only OS 10.13 High Sierra and later actually support NVMe drives, so I'll have to boot from this copy of Catalina just to verify that the NVMe drive is detected. So I'll let this boot up and we'll go from there. Alright, so I was actually able to plug the battery in. As you can see there, that cable was able to reach far enough, but obviously I can't plug anything else in. But as you can see, we are now booted into a copy of Catalina, and there's a good sign already. It actually detects a volume on an internal drive. And of course, there is no SSD installed here, and the only drive installed is that NVMe SSD. So that looks like it's working already, but we'll go ahead and head up to About This Mac. You can see the system specifications there. Go to NVMe, And as you can see, it is indeed working. You can see that the NVMe controller is detected there, that HP NVMe SSD, and everything looks to be working as intended, so that is awesome. Let's go ahead over to the storage tab just for the heck of it here. And yeah, as you can see, there it is, 120 gigabyte solid state PCI Express drive. So that is it. The NVMe SSD is working with this setup. So now I'm going to go ahead and shut the machine back down, remove the cable that connects the NVMe SSD, unfortunately, because it's too short, and then I'll be able to fully reassemble the machine, and from there we can test the GPU off the X8 PCIe slot on the side of the machine. Alright, so as you can see here, I've gotten everything put back together as best as I can. You can see the GPU wires are going through right there. I had to just run them actually under this support here, and you can see I ran the other one that way as well. See, I ran it under that support there, up around here, through underneath the fan here, and I flattened it as much as possible, but there's still a little bit of a raised section here, so it is a little tight, but it shouldn't be a big deal. And then of course those plug in to the two connectors on the xGPU breakout board right there. So with that, I'm going to go ahead and get the bottom put on this machine, and then I'll begin the test by using an NVMe PCIe adapter and plugging that in right here. I think I've got one. If I don't, I've got something else I'll try. And if I can get a connection to that here, that means that the PCIe is working on this slot, and then we can do the final thing of attempting to utilize an eGPU with that slot right there. So with that, I'm going to get the bottom put on the machine, get an NVMe to PCIe adapter installed here, and then we'll test it. Alright, so I couldn't find the NVMe adapter I had intended to use to test this initially, so I went ahead and just decided to connect the GPU to the system. So let me show you how this is all hooked up here. It is quite interesting. So first off here, we've got the PCIe adapter here, so we'll go ahead and unplug it here. Show you what that looks like. As you can see, it's just a PCIe connection there, just a card edge connector, and that plugs in, of course, to the PCIe slot that is inside the system. So that actually just plugs into the optical drive slot, as you can see right there. And as you can see, that just plugs in like so. So just make sure that's fully seated, of course. And then that connection connects to this other PCB that he's made, and this of course has a full-size X16 slot. Of course you're only using half of it because the bus is only X8, but of course you need the full slot for the video card itself. So the video card is plugged in there. This is an AMD Radeon RX 580 video card, so it should work pretty well with OS X. As you can see here, it's also got this like SATA power connection here, and that just supplies extra power to this. So if you don't have a card that has external power like this one does, it'll supply enough without having to run it down these tiny little wires here. So this is actually another board that he's made. It's like a power distribution board, and that gets its power from, as you can see, a 24-pin ATX power supply. Now I've got that connected here. And this last wire here is actually just a signal wire that tells both the power supply and the video card to turn on when the machine itself is on. So basically when you put it to sleep, it'll shut everything off here, the power supply and video card. And of course when the machine's not on at all, neither is the video card or power supply. Now of course the last connection I have made here is the 8-pin PCIe power, and that of course just connects to the ATX power supply like normal. Now of course he did design this to be mounted inside like a small ITX case or something that you could use just as an eGPU enclosure with this extension here, and of course you could add an extra extension for longer cable length to reach your machine. So with that, I'm going to go ahead and boot the machine up into Mac OS. So as you can see there, when I turned the machine on, it turned on both the power supply and the video card. So we'll go ahead and let it load the drives real quick here. And as you can see, I did have to install a different drive with a copy of Sierra on it. It just happened to be what I have, but the Radeon RX 580 is supported in Sierra and later. So we'll go ahead and boot from that volume. And as you can see, our second monitor got a video signal, and of course that's plugged directly into the video card through this DVI cable or HDMI cable there. So we'll go ahead and log in here and see what we've got detected. Alright, so as you can see, we're in the OS. We got the menu bar in that display as well. So let's go ahead into About This Mac. So everything looks normal here. You can see it detects the Intel HD Graphics 3000 internally. Go here, graphics displays, and there is the video card. So you can see, for some reason, Sierra doesn't detect it properly. It just detects it as an R9 XXX, but of course it is a Radeon RX 580 video card, as I said. You can see it's running at a full X8 PCIe lane width, which is perfect. All 8 gigs of VRAM are detected. So let's go ahead and drag our window over here. So yeah, it looks good. Everything looks to be working as intended. Animations look good there. So yeah, awesome. So what I'm going to do now is I'm just going to download a quick benchmark we can run on here, or maybe just a demonstration like, for example, FurMark or something like that. And we'll run this on here and see what our performance looks like. And if it looks all good, this was a huge success. Alright, so as you can see here, I've made this display my main display. Of course, it is the same system. Just so I can show you that. You can see we're running on the 17-inch 2011 MacBook Pro as usual. And yeah, we're running with the Radeon RX 580. So we'll go ahead and close out of this, and we'll run a copy of FurMark for a few minutes. Or not a few minutes, maybe just a few seconds. And as you can see, it is looking very, very good. Buttery smooth. As you can see, GPU's fans have kicked up a little bit here. I did actually have to switch to a different power supply because for some reason that other power supply would shut off every time I put any sort of load on the video card. But this power supply is working perfectly. And as you can see, FurMark is running nice and smoothly on the 2011 MacBook Pro, connected via eGPU or via the optical drive slot to the Radeon RX 580. So go ahead and quit out of that. Let the system. It's running the fans really high now. I'll let the card cool itself back down there. And yeah, that has been a successful upgrade. So as you can see there, that has been the full upgrade with both an NVMe SSD plus an eGPU at full X8 PCI Express on this late 2011 17-inch Apple MacBook Pro. And of course, the last thing we need to do to get this upgrade fully installed is locate a longer ipex cable to connect the NVMe portion with the board fully installed. So with that, I hope you enjoyed this video.